Hello everyone, my name is Darshan and today we will present for the tools for AI. Our topic for the presentation today is graph databases. So let's get started. My group members are Amy, Deepthi, Manish and Monica who participated and helped a lot to prepare this presentation. So our main agenda for today's presentation is introduction to the graph databases, relevance and use of graph databases to the data science and machine learning, application and use cases of graph databases, advantages, disadvantages of the graph databases and challenges of using graph databases in the machine learning, uh, producer and consumer companies for the graph databases and end-to-end scenarios and the conclusion finally. So let's get started with the introduction of the graph databases and we will dive deep as we move forward. So in the simple words, graph database is a database that represents and stores the data as a graph structure which contains nodes, edges and characteristics for the semantic queries. Graph database also use nodes to store the data entities and edges to store the relationship between multiple entities or nodes. Uh, Apart from these, relationships is considered as a first-class citizen in the graph database, and most of the values of the graph database derived from these relationships. Graph database and network model database both used to represent broad graphs. However, graph database provides high level of abstractions and offers simple traversal across a chain of nodes than the network model database. So let's talk a little more about graph databases. In a graph databases, edges always has a start node, end node, and type of a node and direction, and it also have some other attributes like parent-child relationship, actions, and ownership. The relationship between the data are prioritized in a graph databases and these relationships are permanently saved in a database which we can use later on to retrieve the data from database in a quick manner. Relationships can be visualized using graph databases, thus making use of graph database is very useful for heavily interconnected data. And in a graph database there is no limit to the number of nodes and edges, which gives us a flexibility to uh, uh, assign the multiple relationships to the different nodes. Now I would like to hand over to my another group member. Thank you.
Hi, my name is Amy. So I will be explaining regarding the simple example. So traditional database store data to efficiently store fact, but relationship must be rebuilt with the join and other inexact techniques. Graph database store both fact and relationship between the facts, making certain type of analysis more intuitive. Relevance to data science. The graph can potentially hold more information than standard tables because of the flexibility of the model. Machine learning model with information captured from graphs often provide better performance than machine learning based on table shape input. Another point is that the graph itself can be used as an input for machine learning and natural networks, which has piqued and curiosity of many data scientists. This type of neural network is already being evaluated across industry, and some research shows that it improves accuracy. For example, in financial fraud detection, for running such techniques, keeping the original information in graph format for more flexibility is essential. So the graph database is the key component to build workflows that utilize state-of-the-art machine learning techniques. By including feature derived from graph, machine learning model can become more powerful and more accurate. Graph databases are relevant to data science because most of the applications data model needs to support the following, which graph database provide. It has to support many-to-many relationship, the higher value of the relationships, low latency at large scale, and lastly, heterogeneous data. So here I will be explaining regarding the application and use cases based on graph databases. So the most popular use cases of graph database are as follows: financial services, manufacturing, government, data regulations and privacy, marketing, and AI and machine learning research. There are many more, but these are the main example and use cases of the graph database.
So we have used three use cases on graph database solution. The first one is financial services. The problem we choose is money laundering. This involves circular money transfer by criminals who send large amount of fraud, obtain money to himself or herself, but hide it through a long and complex series of valid transfer between normal accounts. Through the database, we have a solution like user can build a graph from transaction between entities that exchange information such as email, passwords, and addresses, and more to make fraud detection easier. An easy query may be run after a graph has been created to discover all customers with accounts that have comparable information and show which accounts are sending money to one another. The second use case we have used is a manufacturing industry. The problem is like a car can have more than 35,000 parts, but what is the impact if we change any sort of part? What if you change a few parts at once? This kind of analysis can be very complicated with a car, where each part can have potentially thousands of dependencies. Now the solution is like by using a graph for a bill of material analysis, you can create a model for analyzing the product information and dependencies. You can also add further information about the products such as vendors, engineers, suppliers, materials, age of materials, etc. to create a variety of models. This enables you to explore component trust, vendor reliability, supplier options, and many more. We have there is a pictures of graph which you can use for the further information. The final use case we have used for graph database solution is a marketing industry. The problem is like in a real-time recommendation, which are becoming more important than ever. But this requires a ability to correlate product information, customer inventory, past customer behavior, current supplier information, logistic, and even social data such as ads clicked and product explored via social media. This is extremely difficult for certain kinds of databases, but we do have a solution from the graph database, and that is with this one can gather all the data, connecting it, quickly identifying the customer requirements and the product trends, and then give them a real-time recommendations because the linkages are already established and the analysis of this interaction to produce suggestion is quick. Many large organizations rely on graph analytics to deliver their recommendation. For further information, you can refer the picture of a graph which we have posted here. Now we are talking about the advantages of graph databases. First one is performance. Graph databases significantly increase performance for complex data relationship management. As the quantity and complexity of relationships rise, relationship searches in conventional database will sputter to a standstill. In contrast, graph database maintain their performance even as your data volume increases year to year. Second one is flexibility. Since the graph model structure and schema may be flexible to accommodate changing applications and industries, graph database allow IT and data architect team to operate at business speed. Data teams can extend the existing graph structure without jeopardizing present functioning as opposed to exhaustively designing a domain in advance. The third advantage is a better problem solving. Graph database solve problems that are both impractical and practical for relational queries. Examples include interactive algorithms such as PageRank, gradient descent, and other data mining and machine learning algorithms.
Continuing advantages of graph databases. First one is agility. As a result, your graph database may develop together with the rest of the application and any altering business requirements, thanks to the excellent alignment of developing with graph databases with today's agile test-driven development processes. Modern graph databases have the tools necessary for painless system creation and maintenance. Next to this is AI infrastructure. Due to the well-structured relational information between items in graph databases, which enables additional inference of indirect facts and knowledge. They make excellent AI infrastructure. Experts in machine learning adore them. Other data models can rarely compare to their rich information and easy data accessibility. Disadvantages of graph databases. First one is there is no standardized query language. The language depends on the platform used. Second is graphs are inappropriate for transactional based systems. Third is the user base is small, making it hard to identify support when running into a problem. Harder to do summing queries and max queries efficiently. Usually need to learn a new query language like Cypher. Fewer vendors to choose from and smaller user base, so harder to get support when you run into issues. Challenges of graph databases. Challenge 1. Modeling highly interconnected data. Because graph databases offer such high levels of expressivity, modeling a domain on a graph is difficult and equates to modeling knowledge or ontology engineering. To represent a graph structure, specialized graph data engineers are required. However, this strategy is not scalable for broad use. Instead, a solution that enables any engineer to quickly represent their domain on a graph without needing to be an expert in ontology engineering or the underlying graph data structure is required. Challenge 2. Maintaining consistency of data. For example, if you have modeled a company that can be related to a person through an employment relationship and a person that can be related to a cat through a has-pet relationship, you really don't want the graph database to allow storage of data that says a cat named Kitty to be employed by the company Apple. Challenge 3. Writing the graph queries itself. Although you can query data with the high degrees of separation when creating graph queries, you must be clear in identifying the path to travel between data instances. You must now construct your queries specifically because you established your model, because your data model controls the connections between your data instances. This type of searching is difficult because your data may not have been modeled using the most general, consistent, and theoretically sound model. Example, sometimes you defined a relationship as a node, other times as an edge.
Hello all. So I'm going to talk about the companies which are currently using the graph databases. So first is the US Army. US Army is using the graph databases to track the equipment maintenance and support. Next we have Caterpillar, which is using graph databases to basically analyze and automate the product maintenance and supply chain management. Further, we have Lockheed Martin Space, which is using graph databases to integrate the processes and the data across the entire product lifecycle. Then we have Volvo company who is using the graph databases to align product design with customer requirements. We also have Daimler who's using graph databases to understand the skill sets in its workforce to bring together the cross hierarchical teams. And the last company to use graph databases is Airbus, which is using it to reinvent their maintenance processes. Let's see an end-to-end scenario of a graph database. So if you consider the example on the left, the following graph is showing us an example of an social network graph where the nodes are the people and the relationships are the edges. Our problem here is how can we find out who the friends of friends are for a particular person. For example, in this graph, we are basically finding the friends of Howard's friends. So in real time, when we use Facebook, we do get the recommendation of friends. That is because it is using graph databases behind the scenes. To conclude the presentation, I'm going to talk about a few conclusions which we came across. The first one is the graph database transform a complex web of dynamic data into meaningful relationships to help us deliver real-time insight and action. The next conclusion is that the graph databases have advantages for a lot of use cases. One such use case is related to social networking, which we saw in an end-to-end example. It also recommends us the engines and fraud detection when you need to create relationships between data and quickly query these relationships. The third conclusion is with graph database search, you can easily query all of your connected data in real time and then focus on the answers provided and launch new real-time searches prompted by the insights which you have discovered. The next conclusion is enterprises can actually structure that data exactly as it occurs and they can carry out searches based on their own inheritance structure. Graph databases also provide the model and query language to support the natural structure of data. The next conclusion is users receive fast, accurate search results in real time. And with graph database, a variety of rich metadata is also assigned to all the content for rapid search and discovery. Finally, data architectures and developers can easily change their data and its structure as well as add a wide range of new data. The built-in flexibility of graph database model allows for agile changes. So these are all the conclusions which we came across. And thank you all for listening to the presentation. I hope you all enjoyed the presentation. Thank you once again.